processes that are really best in class. And then goes on to the robust quality systems, quality management that we have in our production scenarios and the manufacturing facilities we have. The plan that we have for continual improvement in creating better products, creating better scenarios, constantly producing better processes in-house, and then on to things like supply chain traceability and raw material traceability, getting the best vendors that we can to provide the best quality raw materials for us. And then it goes into things like the auditable facilities. We have many facilities that are creating these products in different areas. We host over 200 audits per year in those facilities. We're continually putting investment into the space, over $30 million alone in 2015, into acquiring new facilities or scaling up those facilities for increased capacity or increased quality to make sure that the products that you need to be manufactured in the way that you need them to be made. So we're consistently going out and assessing our quality management systems and trying to improve those to meet the needs that the industry and that the regulators are putting into the space. This is a showcase of many of the sites that are relevant in producing products and relevant for cell therapy users. This is by far not a list of all the sites we have, but showcases many of the sites that produce media, reagents, banana beads, serum, and other products that are typically used within a cell therapy manufacturing scenario. We do this to create redundancy, in many cases across some of the product lines, so that there's not going to be a shortage of supply or issues with being able to provide users in any geographic area with the appropriate products. I think it shows the infrastructure that we put into place to make sure that we have the capacity and the quality and the distribution channels necessary to make sure that you have what you need. I want to give you some specifics on a few things that we've done over the last several years to create products that are more relevant to users within the cell therapy environment. So many of you are involved in immunotherapy, and you realize that the human ABCR that is used in that space is often a major constraint both for security of supply, the potential for contamination, the variability issues. And so we launched a product this year called CTS, immune cell chain replacement. This is a 1-to-1 replacement for human ABCR. And the functional testing we've done has shown that the cells produced, at least in a CAR T-cell environment, are functionally equivalent both in vivo and in vitro to cells produced in human ABCR. It's a chemo-free product, so it alleviates a lot of the concerns around human ABCR. Another product launched this year was GEDC1320. For those of you in the gene modification space that are looking at lentiviral vector production, one of the issues there is that there are titers. GEDC1320 increases the titer production versus our previous product, GEDC1320, between 3 and 4-fold to get much improved titers and therefore more virus, less production loss for the number of patients you want to address. And we're definitely continuing to work in the space to produce higher quality products and products that can be used within the space more specific to lentiviral production. Another product area, not specific product, is AGT or advanced granulation.
Hi, I'm Angel Varela from Thermo Fisher Scientific Cell Culture R&D. Today I will be presenting an overview of our serum replacement supplement CTS Immune Cell-SAR and a case study performed at the University of Pennsylvania where the researchers compared CTS Immune Cell-SAR versus human AD serum for the production of CAR-19. This is a general overview of a workflow for autologous T-cell therapy manufacturing. It involves 4 steps: obtaining a sample from the patient, a selection step to isolate the T-cells, a culture step where cells are expanded and engineered if needed, and finally, the cells are infused back into the patient. Most processes to manufacture T-cell therapies were developed in academia. Due to this, the cell culture processes were not optimized for commercial scale manufacturing. One of the major challenges for commercial scale-up of T-cell immunotherapy is the use of serum as a medium supplement. Key opinion leaders have singled out serum use as a source of variability and high cost for commercial manufacturing. Minimizing variability is a major goal in establishing robust manufacturing processes. A defined cell culture system can help to develop a robust process that is amenable to automation, enabling statistical process control, and leading to a greater color characterization. Serum as a component in cell culture media becomes an impediment in process development. You have lot-to-lot variability, biosafety concerns, and supply chain concerns, since there's really not enough of it to support all cell therapies in development. Consider this study in the right. We tested 6 lots of human AD serum and compared them to a qualified serum lot for T-cell expansion, lentiviral transduction efficiency. We obtained a wide variability between the tested lots in cell yields and transduction, with little correlation between the 2 parameters. These results help to highlight the challenges of using serum in commercial manufacturing process development. Thermo Fisher Scientific has developed a defined serum replacement supplement that can replace human or fetal bovine serum in T-cell culture workflows. The product is xeno-free, cGMP manufactured with a scalable process, and is pre-qualified using functional T-cell assay, which helps ensure acceptable performance with every lot.